Sorry, I was on mute. Um, by the end of this session, learners must be able to calculate percentages as fractions. Learners should also be able to calculate percentage increase or decrease in a quantity. Learners could also aim to apply percentages to savings, borrowing, and wages. Learners will be assessed on their ability to understand how to calculate percentage increases and decreases. So you'll be familiar with seeing percentages in everyday life, such as discount on goods in shops and online, increase in wages, interest rates offered on savings, interest to be paid on loans. And so this is an important task and topic to understand and master. An example, a phone cost £80 last week, but the shop now is offering it with a £5 discount. How much does it cost now? So if you remember yesterday, we did decrease and increase. When there's a discount, it's of course going to be a decrease, so we need to take 5% off £80. So if I put 80, £80, um, so if I'm 10%, if I'm 10%, you do, sorry, 1 second, where is this? To find 10%, you divide it by 10 like we did yesterday, which equals 8. And to find 5%, you half that. So that equals 5. So then to work out the decrease, all you do is 80, take away, no, not divide, sorry, take away 5 equals, so the new price should be £75. Oh, sorry, sorry guys. It's 4, obviously. 80, no, 80 divided by 10 is 4. Divided by 2, sorry, 8 divided by 2 is 4, guys. And then 80 take away 4 is 76. Sorry, that was my mistake. So if you look here, find the first 10% by doing 80 times 1 over 10, or 80 divided by 10 is the same thing, which equals £8. To find out 5%, we halve the result. So dividing by 2 gives £4. So 5% of 80 is £4. However, we need to decrease it from the price. So the new price will be £76. So calculate a percentage increase or decrease. So this is the formula of calculating percentage increase or decrease. In business or commerce, it is also important to be able to calculate a percentage increase or decrease over in the relevant context. For example, the price of a litre of petrol has increased from £1.20 to £1.35 over a period of 6 months. What is the percentage increase? We need to use this formula. So the new value is 1.35. Take away the old value, which is 1.20, divided by 1.35. No, divided by 1.20, sorry. 1.20, so in the context above, 1.20 times 100, so that would be 0.15 divided by 1.20 times 100, which equals 12.5%. Postal rate increases in the UK. Increases in the UK are decided by the government in consultation with Royal Mail. For example, the cost of a first class stamp for a small size letter in the year 2000 was 27 pence. In 2019, it went to 70 pence. What is the percentage increase of the price? So again, what we do is the new value is 70 pence, 0.70, take away 0.27 divided by 0.27 times by 100. So what you do is you do the math. So 0.70 take away 0.27 is 0.43 divided by 0.2. Sorry, sorry, 0.27 times by 100, which equals to, let me get a calculator once. So it was 0.27 divided by equals 0.627 to, let's just do it to three decimal places, 0.628 times. No, we'll do it to two decimal places. No, three. 0.628 times 1,000 times 100. 0.628 to 8%. So, 53. Huh? No, that's wrong. Because 70 take away 27 is not 53. So this what they have done is wrong. 70 take away 27 is 43. So the method would be this way. So it would be 62.8. Guys, ignore this one. As the maths has been done wrong here, because 70 take away 27 is 43, not 53. This is a considerable increase, but both wages and prices have also increased over the 19-year period. Is it a fair increase? To answer this, you will need much more data, such as the rate of inflation over this period, or comparable increases in transport costs. Savings. Another important application of percentages to work out how much interest can be earned on savings and how much you will be charged if you borrow money. We will look at borrowing money later. My bank offers to pay 10% interest a year on any money you invest with them. So if you invest 100 after one year, if you invest £100 for 1 year, after 1 year you will receive an interest of 10% of 100. So that is £10. Often you leave your savings in the bank for a number of years and will continue to receive interest on any money in the account each year. This can continue year by year. So next year you will invest 100 plus 10, so £110 and receive at the end of the second year of amount £11 because it's 10% interest. Now you have £121 to invest in the next year. Compound interest. We will reinvest the interest each year. It is called compound interest. When we reinvest the interest each year, it is called compound interest. We will now we will know how the value of an account increases each year. We will see now how the value of an account increases each year. Here's the account of over a 6 year period. Complete the entries. So year one, two, three is completed for us. Count at the start of the year the interest earned. So the next one will be Start of the year will be 133.10, and then the interest will be 10% of this, which will be 13.31, and then you add this on, which will be 133.10 add 13.31, which would be 146.41. Um, and the year after, it will be 146.41 pounds. 10% interest, remember, we'll round it up so the interest will be 14 pound 64. If you add it on to the answer, to the total, it would become 1464. Oh no, 5164.05, and then 161.05. 10% of that will become, if we round it up, will become £16 and 11 pence. And if we add that on to the answer, it would be 161.05. Add 16.11, which will become 177.16. 7, so if I take this all off and you look at the answers, similar to what I wrote, exactly the same as what I wrote, because here's the answers. Compound interest formula. There is in fact a formula that gives the total at the end of each year. If you invest £8 and the interest is R%, then after n years, the account will be worth the value of the account equals A brackets 1 plus R over 100 to the power of n. We will check this. We will check this for the example above. Here, £100 is A, R is 5, and 6 is n, giving the account value of A would be 101. It shouldn't be 10, should it? It should be 5, sorry. It should be 5. It should be 5, guys. So if we do it, it would become 100. Simplify the brackets, so it would become 105 over 100. Simplify to 21 over 20, I believe. 21, 21 over 20 to the power of 6, which equals, if we do this in the calculator, so 21 over 6. Sorry. 21 over. mm, Bring the calculator. Yeah. Okay. So here, if we do 21 over 20, which is divided by 20, the answer of that is 1.05 to the power of, what was it, 6 equals 1.3 times 100 and 100. So that's this case 34 um, one decimal to do decimal places. Not that multiplied by each year. How long will it take to reach £200? Should be easy to calculate as 1.1 to the power 7, 1.9487, so 1.1 to the power 8 would become 2.14358. So after 8 years, £100 invested would be worth 214. It would take 8 years. Borrowing. This works in a similar way to saving, except that you have to pay back the original sum borrowed with interest added in each year. This can be very dangerous, particularly if you use loan sharks to obtain the money you want. So, for example, suppose you borrowed 500. So suppose you borrow 500 at the beginning of the year with an interest rate of 30% per year. How much would you owe at the end of the first year? So at the end of the first year, you owe £500 plus interest. So 500 plus 30% of 500, which is 500 plus 150. So you owe the lender £650 at the end of the year. If you cannot pay back anything at the end of the second year, you would owe 30% of 650 plus 650. So that would become £845. So beware when borrowing money. Make sure you can pay back the loan ASAP. Borrowing, take care. Complete this table to see how much you will owe after 5 years, having borrowed £200 with an interest rate of 25%. Where needed, work out to the nearest penny, which that means to two decimal places. So if we add the interest to £312.50, so we need to work out what 25% of £312.50 is. If we do that in our calculator, all we need to do is 300, which is 78.13 to two decimal places. So the total would be 300. 312.50 plus 78.13, which equals 390 pound 63 pence. So 390 63 pence. Find out the 25% of that. You just multiply that by 0.25, which equals to £97 and 66 pence to two decimal places. 97 pounds 66 pence. So if we add that to 390, um, 63 pence, it equals to £488 28 9 pence. So 488 £29. So then if we put £488 £29, find out 25% of that is multiplied by 0.25, which equals £122 and 7 pence. So if we add that to 488 £29, the total equals £610 36. And so if you take these off, you'll see that the answers are what I wrote there, 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 and there, and there. Yeah. So there are the answers there. In practice, it can be much more complicated with interest charged monthly or even daily until you have paid back the loan plus interest. It is important that you fully understand the terms and conditions for any financial loan before agreeing to it. Wages. When you are paid wages, you also have to pay tax and national insurance depending on your age and wage. Here we will consider an increase in wages. Suppose you are paid £12 per hour, working 8 hours a week in a cafe. You are given a pay rise of £6. How much extra would you receive each week? So we need to work out the weekly wage, which is 12, um, 12 times 8 is, this is per day, 12. No, this is per week, sorry. So you work 8 hours a week, so 12 times 8 equals 96. So you earn £96 per week. You're given a pay rise of 6%. So to work out 6%, we can do it in our heads by working out 5%. So 10% of this is £9.60. 5% would be divided by 2, which equals £4.80. So that's 5%. And to work out 1%, all we do is 96 divided by 100, which equals 0.96. So to work out 6%, we do this, add this, which equals to 4, 4.8, add 0, equals £5.76. So 6% equals 5.76. So the increase, you would receive £5.76 more each week. Um, yeah. So there's the answer if you see. So we work out 6%. They've just done it on a calculator. You can do that on a calculator or you can do it in your head like I did it. But yeah, the answer is £5.76 per week extra earning with the 6% increase. So metric units. We will start with revising metric units of capacity before moving on to conversion between metric and imperial units. So in metric units, liters are the key measure, and we have smaller units, centiliters and milliliters. They are related by, so 1 centiliter is 10 milliliters, 1 liter is 100 centiliters, and 1 liter is 1,000 milliliters. So using the conversion chart here, what is 27 milliliters? So 27 milliliters, if 1 liter is one liter, I mean, if 1 centiliter is 10 milliliters, that means 27 would be 20 so times 10, which is 20. No, divided by 10, sorry guys. Divided because it's into centiliters, it would be 2.7 CL. Yeah. What is 350 centiliters into liters? So 350. So if 1 centiliter, if 100 centiliters is 1 liter, that means 350 centiliters is 350 divided by 100, which is 3.5 liters. So what is 450 milliliters into liters? So 450 ml divided by. So if 1,000 milliliters is 1 liter, that means 450 milliliters would be into liters would be divided by 1,000, which would become 0.45 liters. Yeah, which is 2.5 liters into centiliters. So 2.5. So if 1 liter is 100 centiliters, that means 2.5 would be 250 centiliters. What is 2.5 centiliters into meters, into milliliters? So 2.5 centiliters. So if 1 centiliter is 10 milliliters, that means 2.5 centiliters would just be 25 milliliters. Yeah, cool. So the imperial unit for capacity and gallons, pints, and fluid ounces are gallons, pints, and fluid ounces. They are related by 1 gallon is 8 pint, 1 pint is 20 fluid ounces, 1 gallon is 160 fluid ounces. So using the chart, convert 2.5 pints into fluid ounces. So if 1 pint is 20 fluid ounces, 2.5 pints would just be times 20, not 10, would become 50. Yeah. To convert 36 pints into gallons. So if 1 gallon is 8 pints, 36 pints will be divided by 8, which equals, if we do in the calculator, 36 divided by 8 equals 4.5 gallons. Let's convert 3.24 gallons into pints. So if 1 gallon is 8 pints, that means 3.24 gallons would become how many pints of 3.24 times 8, which would become 25.92 pints. Yeah. And convert 68 fluid ounces into pints. So again, if 1 pint is 20 fluid ounces, so 68 fluid ounces would be 68 divided by 20, which is 3.4. Now convert between metric and imperial units. Use these approximations. So it tells you imperial to metric, 1 milliliter is 0.0352 fluid ounces, 1 centiliter is 0.352 fluid ounces, 1 liter is equal to 1.76 pints, 1 liter is equal to 0.220 gallons, 1 fluid ounce is equal to 28.41 ml, 1 fluid ounce is equal to 2.841 cl. 1 pint is equal to 0.568 liters and 1 gallon is equal to 4.546 liters. So using this, complete the following table. So fluid ounces to centiliters. One is 2.84. So you do 480 divided by 2.84 equals, to do decimal places, you can do 168.95. So 120 fluid ounces would just be 120 times 2.841, which equals 340.92. And then 250 centiliters would be 250 divided by 2.84, which would be 88 to 188 to 2 decimal places. Yeah. So if we look, take these away, we'll see the answers are there. Exactly as I wrote them. 24 liters to pints, so all you do is times it 1.76, so 24, which equals to 42.24. So 40 pints is equal to 40 divided by, yeah, 40 divided by 0. No, so yeah, 40 divided by, sorry, 40 divided by 1.76 pints. So 1.76, 22.73, and then 150 liters would be 150 times 1.76 to find out the pints, which would equal to 264. Well, again, if we take this away, this is rounding it down, I've rounded it up. So, sorry, sorry guys. The answer. Also, scale drawings. Scale drawings are accurate plans drawn to a given scale to be used by builders and construction workers when working on projects. There is an example of a plan of a workshop and store. So if we look at this, the scale is 1 to 120. What is the total width of the two windows? in the lounge diner. So the total width of the two windows, the lounge diner, would be three times three times 120, which is 360 centimeters, because there's three windows. If we look there, so three times 120, which would equal 360, and which equals to 3.6 meters. What is the floor area of the kitchen? So the floor area on the plan, the kitchen measures by 1.5 cm to 2.5 centimeters. Um, so that this is 180 by 300 in the actual kitchen. So the area is 180 by 300, which is 54,000 square centimeters, which equals to 55.4 meters squared. What is the total floor area of the lounge? The total floor area of the lounge. The lounge is formed by two rectangles on the plan. So it's formed by two rectangles on the plan. Take away one. So, sorry, one 3.5 centimeters by 3, and the other 2.5 by 1.5. So the smaller rectangle has the same as area as the kitchen. The larger one is 420 by 360, which is 151,200 centimeters squared, um, which equals 15.12 meters squared. So the total area is 15.12. Add the old one, which is 5.4. So the final answer would be 20.52 meters squared. In practice, we often have measurements and a rough sketch use use to make an accurate scale drawing. For example, the diagram opposite is a rough plan of a room. We need an accurate plan to scale of 1 to 50. We write this as a ratio 1 to 50, meaning that 1 centimeters on our accurate plan will represent 50 centimeters in the actual room. So the length 3 equals 300 centimeters. 3 meters equals 300 centimeters. And so working on a scale of 1 to 50, we divide it by 50, which equals 60 centimeters in our plan opposite. So 5 meters equals 500 centimeters. So 500 divided by 50 equals 10 centimeters on our plan. 2.5 equals 250 centimeters divided by 50, which equals 5 centimeters. Similarly, 2 meters is 4 centimeters. 1.5 is 3 centimeters, as shown in the plan opposite. Map scales. Scale drawing includes from maps. Here is a map of England drawn to a scale of 1 to 4 million. On this map, what is that? What actual distance does 1 centimeter represent? So 1 to 4 million. So it means that 1 centimeter represents 4 million centimeters, which equals 40,000 meters, and which equals 40 kilometers. Yeah. So on this map, the distance from Exeter to London in a straight line is 6 centimeters. What is the actual distance? So if 1 centimeter represents 40 kilometers, that means 6. You will multiply by 6 to get 6 centimeters. Multiply that by 6, which equals 240 kilometers. The actual distance from Birmingham to Manchester is 120 kilometers. What is the map distance? So if we do again the ratio 1 to 40 kilometers, 1 to 40 km. 120 to get to 120. All you do is multiply by 3 to get to 120k. And so multiply this by 3 as well. It equals 3 centimeters. Yep. So the answer is 3. Complete this table of conversions from marked to actual distances. So 8 centimeters of scale is 50,000. So all you do is 8 times 50,000. 8 times 50,000. So if 8 centimeter times 50,000 equals 400,000 centimeters, that is 400,000 centimeters. So to convert that into kilometers, all you do is divide it by um it would be, I think it should be divided by 100 and then divided by, it should be 4 kilometers if I'm not wrong, 0.4. So it would be divided by 1,000, which is 40, no, which is 400, and then divided by 1,000 again, which is 0.4 kilometers to work out the kilometers. Again, this converted into centimeters, you just times it by 1,000, which equals 10,000 times another 1,000, which equals 10,000. Another 1,000. That's how many centimeters there are, which is 10 million, I'm pretty sure. And then divide that by 25 to work out what the actual is. So 1, 2, 3, 4, 5, 6, 7. There's 7 zeros in that divided by 25 equals 400,000. Is it? Yep. No, 25,000, sorry. 25,000 divided by, so it's equal to 400. It should be 400 centimeters. No, sorry, that's the wrong place I wrote it in. It should be 400 according to me. 400 and 40 centimeters. How is it 40, guys? Oh, yeah. Divided by 25,000. Yeah, so it's 40 centimeters, not 400. And then the scale of that. So all you do to find the scale is, again, to convert it into centimeters or centimeters. Let's convert this into centimeters. So 20 kilometers into centimeters equals 20 times 1,000, which is 20,000 times 1,000, so it becomes um, 20 million. So 20 million centimeters. So that is 8 over that. Sorry, sorry, 1 second. Um, 10. Don't, sorry, wait. I think it's 2 million. So it'd be 2 million. Not 20 million. Sorry, I was doing that wrong. That's 2 million. So what we would do is we would do 2 million divided by 8 centimeters, which equals, I think it should be 1, 2, if I'm not wrong, 1 to 1, um, 1 to 125,000 actually, yeah, because you divide it by 2. And the last one would be 200 kilometers because you multiply, if one, you multiply 4 by 5 million equals to 20 million, 20 million centimeters divided by, yeah, so 20 million divided by 1,000, which equals 20,000 divided by 100, which equals 200 kilometers. So it becomes 200 kilometers. Compound measures. In previous units, we have looked at measures of length, weight, and capacity. Here we will consider some compound measures such as speed, density, and rates of pay, etc. For speed, you will probably have some knowledge about speed. You can walk faster at about 4 miles per hour, run at about 10 miles per hour, and cycle at about 20 miles per hour on a motorway. On a motorway, you are allowed to travel up to 70 miles per hour, and our fastest train travels at 125 miles per hour. So, what does 4 miles per hour actually mean? So, it means if you continue at this speed, you will travel 4 miles in an hour, whereas the high-speed train would travel 125 miles in the hour. We calculate the average speed by dividing the miles traveled by the times taken in hours. So, for example, Lucy drives from Plymouth to Southampton a journey of 161 miles in 3 hours and 30 minutes. What does that for 3 hours 30 minutes? 3 hours 30 minutes into time is 210 minutes. So to work out the average speed, all we do is the distance divided by the time. So 161 divided by 210 minutes. What is her average speed? Which equals 161 divided by, that's per minute. So we need to do, sorry, divided by, yeah. So we need to do per hour. So she travels 161 in 3 hours and 30 minutes. 3 hours and 30 minutes. That means in 1 minute she will travel. In 1 hour she will travel 3 hours and 30 minutes, 3.5. So you just divide it by 3.5. So 1 divided speed would be 1 divided by 3.5 because it's 3 hours and 30 minutes, which is 46, if I'm not wrong, mile per hour. Yep, 46 miles per hour. Because you just remember, ignore the minutes. We don't do it in minutes, we do it in hours. So all you need to remember is that 3 hours and 30 minutes, 3.5 hours. Then you work out. Care must be taken to put time into hours. Suppose speed is the distance divided by time. So a lorry driver keeps record of each journey he makes. Calculate the average speed for each journey in the table below. So the first one, it takes 4 hours to travel 172 miles. So all you do is 172 divided by 4, which equals 43 mph. Second one, it takes him 5 hours. Yeah, 5 hours to travel 280 miles. So we do 280 divided by 5, which equals 56. It takes him 6 hours to travel 300 miles. So 300 divided by 6, which equals 15 miles. It takes him 2.5 hours to travel 120. So all you do 120 divided by 2.5, which equals 48. 8. And the last one is it takes him 5 hours to travel 174 miles. So 174 divided by 5, which equals 34.8 and 8, 43, 56, 37.5. How's it 37.5? So it takes him 8 hours, sorry, not 6 hours. Yeah, sorry, I got that one wrong. Because it's 8 hours, I assumed it's 6 hours, which is wrong. So 37.5 there. This is 48, and the last one is 58. How is it 58 again? So you do 134 divided by 5 hours. Why is it 58? I don't know why it's 58 because 174 divided by 5 on the calculator is giving me 34.8. So I feel like this one is wrong, guys, unless I'm mistaken. Um, Let me just work out 300 divided by 8. Yeah, so this one's correct. And this one should be 174, which is the distance, divided by the time, which is 5 hours it's taken. So the answer is 34.8, guys. It's not 58. That's the right answer. Um, Distance traveled, as well as calculating the speed. Given the speed and time, you can calculate the distance travel. For example, if you travel at 60 miles per hour for 3 hours, you have traveled 180 miles. Similarly, you can calculate the time taken by dividing the distance by the time taken. So if you have traveled 150 miles in 3 hours, you have traveled, the time taken is 50 minutes, not 50 mph. 50 minutes. No, if you travel, oh, this is doing it wrong though. If you travel 150 miles at the speed of 3 miles per hour, again, no, at the speed of 3. Yeah, so here's the formula, guys. Distance travel and time taken. So Jane drives at an average speed of 45 miles per hour on a journey of 135 miles. How long does the journey take? So the time is the distance over the speed. So 135 is the distance of 45 mph, which equals to, if we do that, that is 3 hours. Chris cycles at an average speed of 8 miles per hour. If he cycles for 6.5 hours, how far does he travel? So distance is the speed, which is 8 times the time, which is 6. So he 6.5, sorry. 6. So it is 6.5 multiplied by 8, which equals 52 miles. Yeah, density. This is another compound measure for how dense a material is. For example, a container full of sand would be much heavier than the same container full of air or bubble wrap. This is because sand is more dense than air. Density, weight, and volume are connected by the following relationship, which is written in the formulas here. Density example. So a metal block weighs 2 kg. The block has a dimension of 5 by 10 by 20 centimeters. Calculate the density of the metal block in grams per centimeters and in kilograms per centimeters. So in grams per centimeters, so 2 kg equals 2,000 grams. 2,000 grams, yep. So to work out the density, it is the weight over the volume. The volume is 5 times 10 times 20, which equals um, to 1,000 cm cubed. So to work out the grams per centimeters for the density, it is the weight, which is 2,000 grams over the volume, which is 1,000 centimeters. You be cm cubed, which equals divided by 1,000 to work out the gram. 2 kg per cm cubed. So that's the answer in kilograms per centimeters cubed, and that's the answer in grams per centimeters cubed. Other compound measures, for example, Alison scores 27 goals in 40 matches. Calculate her average scoring rate. So the goals per match would just be, this would just be 27 by 14. So her goals per match is 27 divided by 40 is 0.675 goals per match. Goals per minute. So each match in 90 minutes. So if she scores in 40 matches, all you do is 40 and 90 minutes per match. That's how many minutes played, assuming she's not being substituted. 40 times 90 is 3,600 minutes. So goals per minute would be 27 divided by 3,000, 3,600. So the answer would be 27. Not 7.5 goals per minute. Goals per hour. Oh, so this becomes a bit more. So goals per hour would be, if we work out goals per minute times So you just times it by 60 if that's goals per minute to work out the goals per hour. So that gives us 0.45 goals per hour. So if you look there, that's the first number. Second one is 0.075, like I said. And the last one should be 0.45, like I said. Cool, guys. So that was today's lesson. What we learned was a lot of averages, conversions of metrics and imperial units. We learned division of fractions and percentages. And yeah, that was pretty much it for today's lesson. If you've got any questions, just let me know. But otherwise, thanks a lot. And I'll share both recordings on the group chat. And yep, hopefully see you guys next week. Thank you.
Thank you very much.
Thanks a lot.
Thank you. Bye-bye.
Bye.